Civil engineering students. So you would have heard about Clapeyron's theorem of three moments. Today we will solve a simple continuous beam. There is a two-span continuous beam with an overhang using theorem of three moments. So you can note down that the point A is fixed and point B is supported by a roller. Point C is also supported by another roller support. And here you have an overhang for 2 meters. Which is then acted upon by the concentrated load, which is a point load, that is 20 kilonewton. So Clapeyron's theorem of three moments states that M1 L1 divided by EI1 plus 2M2 into L1 by EI1 plus L2 into EI2 plus M3 into L2 divided by EI2 equal to minus 6 A1 X1 by EI1 L1 minus 6 A2 X2 by EI2 L2. Now M1 denotes the moment at point 1, M2 at point 2 and M3 at point 3. L1 and L2 denotes respectively the span 1 and span 2. And A1 is the area of the bending moment diagram for the particular loading. And X1 is nothing but the centroidal distance between the loading and point 1. And similarly A2 is the area of the bending moment diagram drawn for the next span. Second span, and X2 is the centroidal distance. And if EA is constant, the same equation can be written as M1 L1 plus 2 M2 into L1 plus L2 plus M3 into L2 equal to minus 6 A1 X1 by L1 minus 6 A2 X2 by L2. Now please note down that here the span A is fixed. So for this the procedure is different from the usual procedure. So we can add an imaginary span. So you can see that an imaginary span is added here. So this imaginary span is having a length of L dash, and it has a moment of inertia about infinity. Now writing down the Clapeyron's equation, we have here three moment equation as M A dash into L dash by infinity E plus 2MA into L dash by infinity E plus LAB by EI plus MB into LAB by EA equal to minus 6 A1 X1 by E infinity L1 minus 6 A2 by EI into L2. So what we can do is anything divided by infinity, this term becomes 0, and also this term becomes 0, and this term also becomes 0. So we are left out with here MA dash into 0 plus 2MA into 0 plus 4 plus MB into 4 divided by EI equal to minus 6 A1 X1 by E infinity L1 minus 6 A2 X2 by L2 into EI. Now we have only MA and MB. So this equation will have MA and MB, and we will try to evaluate what is A2 and what is X2. Now here you can see that this is the point number 2 and this is the point number 3. Okay, so for this you can see that you consider this span as simply supported and evaluate the bending moment diagram. So bending moment diagram says that the reaction at each point is 20 kilonewton and 20 kilonewton. Because the loading is symmetric and also the loading is symmetric, as well as the point of application of load is symmetric. So because of that you can see that the bending moment diagram is 20 into 2. So this is the triangular bending moment diagram. Okay, the span is also symmetric and the loading is also symmetric. Now A2 equal to half into 4 into 40. So because you have base into height as the area of the triangle, and X2 equal to 2 meter. So if you have the centroid here, from this point to this point it is 2 meters. So we will substitute here and we will write down the equation. So here you can see that 2MA plus 4MB equal to minus 6 into 0 minus 6 into half into 4 into 40. So this is A2 multiplied by x2 2 divided by length 4. So here this is area of the triangle and there is A2, and this one is X2. So substituting all the above, finally we get here 8 MA plus 4 MB equal to minus 240. This equation is 1. Equation number 1. Then here you can see that the next span is taken here. That is, here you have MA, here you have MB, and at this location you have MC. Okay, so this is 1, 2 and 3. So we will write down the Clapeyron's equation. M1 into, this is 4 meter, this is 6 meter, and M1 into 4 plus 2M2 into 4 plus 6, L1 plus L2 plus M3 into L2 is 6 equal to minus 6 A1 X1 by L1 minus 6 A2 X2 divided by L2. You note down that EA is constant. Okay, so no need to divide this by EA. Now we have to find out what is A1, what is X1, what is A2, what is X2. So all these should be found. Now here, for the span AB, the bending moment diagram is a triangle, and you know this is 40 and the base is 4 meters. So this is 4, and here you have a load of 40 kilonewton. So this is A1. So A1 equal to half into 4 into 40, and X1 equal to, so centroid is located at this point. From here to here, the centroidal distance is 2, and A2. So how will you find out A2? You take the next span BC, where UDL is applied, 10 kilonewton per meter. So here the bending moment diagram is, here it is WL square by 8. So we can find out A2 equal to 2 by 3 into BH equal to 2 by 3 into base is 6 meter. So 6 into W is 10 into L is 6 square by 8. Now this is your A2, and X2 equal to, if the centroid is located here, from this point to this point, the X2 is 6 by 2, that is equal to 3 meter. Okay, this is how we evaluate. Then after that we have to substitute in the equation. So M1 into 4 plus 2M2 into 4 plus 6 plus 6 M3 equal to minus 6 into half into base into height for the triangle into X2, X1 is 2 divided by L1 4 minus 6 into 2 by 3 into base, 2 by 3 into base is 6 into WL square by 8 is 10 into 6 square by 8. Then you have X2 as 3 meter divided by the length is 6 meter. So this is A1, this is X1, this is A2, this is X2. Now here there are 3 unknowns. Okay, so M1, M2, M3. M1 is MA, M2 is MB, M3 is MC. So we have to substitute this value of MC equal to minus 40 kilonewton meter in this place. So M3 equal to MC. MC equal to 20 into this distance is 2 meters, 20 into 2 minus 40 kilonewton meter. That we have to substitute. So rewriting the equation again, we have here 4 MA plus 2 MB into 10 plus 6 into MC is minus 40 equal to minus 240 minus 540 after simplification. So finally you get an equation here 4 MA plus 20 MB equal to minus 540, and we know already we found an equation. First equation was 8 MA plus 4 MB equal to 8 MA plus 4 MB equal to minus 240. So solve these two equations, which implies MA equal to minus 18.33 kilonewton meter and MB equal to minus 23.33 kilonewton meter. So these are the support moments. Once you are done with the support moment, then we have to calculate the reactions. So how to calculate the reactions? So that we have to draw the free body diagram. So this is the free body diagram of the entire continuous beam. So this is the fixed support A. Then you cut a point here. Here you will have this MA and RA, and at this location you know that the point B is 23.33, and the next span BC you have 23.33, and MC is acting in this direction, and it is being balanced by another moment MC in opposite direction. So here you don't worry about the negative sign or positive sign. You just draw this moment in this convention. And then what we have to do is we have to separately draw the bending moment. Separately we have to segregate all the beams, and then we have to find out the reaction. For example, we will take this span first. Span AB will be taken. So for the span AB, you know that here we have 18.33, and at this location you have 23.33 as the moment, and this is RA, and this is nothing but VB dash. Now take moment about point B equal to 0. So what you will get is RA into 4, so it is in clockwise direction, plus 23.33, then minus 18.33, then you have here minus, you have a load here, so 40 minus 40 into 2 equal to 0. This gives us RA equal to 18.75 kilonewton. Now once you know RA, you can evaluate this VB dash. So VB dash obviously equal to 40 minus RA, that is equal to 21.25 kilonewton. So this is how we evaluate. Similarly, you can solve these two spans also. So you can see that this is the reaction RB. It is equal to VB dash plus VB double dash, and the reaction RC equal to VC dash plus VC double dash. So here you will get RC like this. RC will be something like this, that is separated in this form. So this RC equal to VC dash plus VC double dash. So next span we will take and we will evaluate. We will evaluate the span BC. So you take this span BC and you apply 10 kilonewton per meter. Here it is MC, and at this location you have VB double dash and this VC dash, and here it is 23.33. So take this is point B and this is point C. Take moment about point C equal to 0. So you will have VB double dash into 6 plus MC minus 23.33 minus 10 into 6 into 3 equal to 0. So you can imagine that VB double dash divided multiplied by this length lever arm distance is 6 meter. It will give you positive moment. So MC is taken positive here. This in this direction it is assumed. So plus MC minus 23.33 because anti-clockwise, and this load also causes anti-clockwise moment. So substituting all these things, you will be getting VB double dash equal to 27.22 kilonewton. Then how will you find out VC dash? VC dash is equal to 10 kilonewton into 6 minus 27.22. So that will give you VC dash. So VC dash equal to 32.78 kilonewton. Then we will calculate RB equal to VB dash plus VB double dash equal to 48.47 kilonewton. Then VC dash has been found. We have to find out what is VC double dash. So here it is 20 kilonewton. This is point C. This is VC double dash. Now VC double dash equal to 20 kilonewton. Obviously, because these forces balance each other, this span is 2 meter. Now VC double dash has been found. VC dash is known to you. VC double dash is known to you. So RC equal to VC dash plus VC double dash. So which gives us 52.78 kilonewton. So this is how we calculate the reactions. Most of the time in these problems they ask you to calculate the reactions also. So next we will see the bending moment diagram. So here you know that the moment at this point is 18.33. At this point B it is 23.33. Here you have an overhang portion, that is at this location you have a moment of 40. Then in overhang you have 0, so you join this like this. Then you can see that it is point C, it is point D, it is point B, it is point A. So this is how you draw the bending moment diagram. Thanks a lot for watching. If you have any doubts, you mention in the comments. Please share and subscribe. Thank you.